So I'll talk a bit more then about leveling. This is a very, very important concept, and this is one of the when I talk about the penny dropping moments. This is one concept that I can say purely from experience that about 20 to 30% of everyone here will get by the time I'm finished this slide. It's a concept that I find that the penny drops at different stages for different people. It's just because it's not, and I'm not saying this out of any great boast of how I went through the same procedure. That's why when this was explained to me first as to why just being volatile incurs a cost, and that just focusing on volatility alone actually can give you these savings of 20 to 60%. On the y-axis, I have workload. So workload can be number of samples or the hours effort it takes to do a sample. So it's the workload that's coming into the lab. And on the x is over a period of time. So the sinusoid is meant to represent a volatile arrival of samples into your lab. So the point being that on one day you might have that many samples, on another day you've got a peak, on another day you've got nothing. It's an extreme example, but nonetheless, it's you're all familiar with this idea of we're very busy one day and we're not very busy the next, and that volatility has cost implications. So if it was an ideal world, every set of data has a mean or an average, and that represents the leveled demand rate. So over that period of time, if everything had come in evenly, that's what it would have averaged out at. So that's my average number of hours or my average number of samples coming. But obviously, I need to resource our labs or any organization, or this could be for any process. You have to resource, because you've got the volatility, you have to resource somewhere above that mean in order to do business. So you'll resource typically somewhere up the curve to do business, and the difference is the excess cost or additional capacity that you need to do business. However, even by doing that, you're never going to get budget to run at your busiest day. So you're still going to run late, even though you've manned up that curve. You're still going to run late on days when you get extreme peaks, and you're going to be unproductive, extremely unproductive on the trough days, where you don't have work but you have the resources there. You can't just swap people in and out to meet them. So that is a key concept of the reason that volatility incurs cost. And I guess a key point is, when you do a lean lab project, you're looking at how high up that curve are you as a lab, and how close to that green line can you bring that purple line? Can you bring it right down? Now, before I leave this slide, I'll say one other thing, is that throughout the presentation I might refer to the leveled demand rate, and this green line is the leveled demand rate. But in essence, many labs may never be able to get to the leveled demand rate, but you can get to what I call the levelable demand rate, because depending on your service level agreement to the rest of the business, you know that you can't ever be at the leveled demand rate. You will never be at the exact average. You may have to be somewhere above, but not as far above as that purple line is. So you can replace leveled for levelable. Levelable meaning that I'm at a level of resource which will still honour my service level commitments. So this is a similar curve to the one we've just seen, just showing some real data on it. So this will be an example from a site where, for all of my different sample types, there is this type of volatility. When you do your analysis, this is a week by week number of samples arriving into the lab. It's just an amalgamated list showing a similar up and down. Now, these curves I'm showing are sinusoidal. Every data will have a different type of a curve, but lots of the time you're looking at volatility in some shape or form. So what Lean Lab, or what a leveling strategy is about, is leveling the demand that's placed in the lab to make this absolutely beautifully perfect weekly amount of work, which is obviously ideal for the purposes of demonstration. But the wall through which the way you do it is this is the high junkai devices called rhythm wheels, trains, and sample cues, which I'm going to explain now how they work.